This video provides an introduction to Keras and TensorFlow, two powerful frameworks for machine learning. The outline covers the background of NVIDIA CUDA GPU, installation steps, basic skills for writing a machine learning model, and a specific case study, the XOR gate. Keras is a Python package that serves as a high-level neural network API, running on top of TensorFlow. It is open source, runs seamlessly on CPU and GPU, and requires less code to build and run a model. TensorFlow is an end-to-end platform for machine and deep learning, supporting Python and C++. It is multi-platform, open source, and runs on CPU or NVIDIA CUDA GPU, though it typically requires more coding lines. The NVIDIA CUDA toolkit is a C++ library and a parallel computing platform for NVIDIA GPUs. It's often relied upon for GPU-accelerated computing in deep learning. To get started, you will need to install Anaconda 3. Download it from the official website and follow the installation steps. A restart may be required. After installing Anaconda 3, open the Anaconda Navigator. Navigate to Environments, choose All, and search for TensorFlow. Install TensorFlow and Keras for CPU, or TensorFlow GPU and Keras GPU for GPU, ensuring CUDA compatibility. To confirm the TensorFlow installation, run the provided test code. If the installation is successful, you should get the answer 3. For Windows users, Keras requires backend settings, which involves setting the backend to TensorFlow in the Running the Keras test code should output using TensorFlow backend. Keras offers two main types of models: the sequential model, which is easy to learn and uses a linear stack of layers, and the model class with the functional API, which is more flexible. The Keras sequential model involves defining the model layers, compiling it with an optimizer, loss function, and metrics, training it with data, and finally using it for prediction. The XOR gate case study demonstrates the process in Keras. This involves importing necessary packages, preparing the input and output data, building a sequential model, compiling it with an optimizer and loss function, and then training and predicting. The training log for the XOR gate example shows that after many epochs, the model achieves 100% accuracy and a low loss. The prediction results are also displayed. In TensorFlow, a tensor is an object that allows defining operations. A TensorFlow model is a function with learnable parameters that maps input to output via these operations. It offers more flexibility but is more complex than Keras. You can build a machine learning model in TensorFlow using two main ways, either with the layers API for higher-level abstraction or the core API with lower-level operations. The XOR gate case study using TensorFlow involves defining placeholders for input and labels, building layers, defining the cost function, and using an optimizer. A session is then started to train and test the model. Here is the TensorFlow XOR gate training log and test results, showing the loss decreasing over epochs and the final predictions. Consider what happens if kernel initialization is removed in both the Keras and TensorFlow models. Reflect on whether the results are stable and what might be the potential cause of any instability. In summary, Keras is user-friendly with high-level APIs for quick model construction, although training convergence may be unstable. TensorFlow is flexible for developing new models, multi-platform, and has strong community support, but is less friendly for new learners. Thank you for watching this video.